Okay, so now the next section we're going to look at is the format command. This is going to be very useful to us. Let's kind of pop this in here. So we have a cylinder. We love cylinders. And we're going to set h to be some weird number like 10 to the 0.5 power, so the square root of 10. Right, so h is kind of weird. And now we can calculate volume. And I am going to cheat with volume in the print statement. Right, and volume is some weird value. And now we can do our print. And this is something you guys, I think, ran into it at some point. At least it was in the discussion forum. You know, this is pretty messy. And it's really not all that legible. And quite honestly, if we're doing experimental stuff, you know, most of these are probably not significant digits. They're just leftover measurement errors, etc. We don't have any confidence that they're actually of value. So this brings us to something called the format statement. So let's look at what the format statement might actually appear to be. So the format statement takes a string, right? So it takes a string, right? This is a string. And inside the string, you put these little format specifiers. Okay? And then format is a method, is a function that works on a string. And what it does, so when you put dot format, you then give it these arguments, right? R, H, and V. And what it does is it scans through this string looking for these format specifiers. Right? So now if we look at outstring, what we find out is that outstring is gone through, and where it finds these specifiers, where it finds the specifier with 0, it takes the 0th argument, the R, replaces the R with, replaces this format specifier with R, and for this case, it uses, you know, this is a 0:.2f. So the F says it's floating point format, the .2 says you want 2 decimal places, and the 0 says it corresponds to the 0th argument supplied to the format, right? So 2.5, our R was 2.5. That's correct. H corresponds to the 1, right? That's the first argument. If you start at 0, R is 0, H is 1, the volume is 2. Right, again, we say put it out in floating point format with 2 decimal places, and the same with the volume as argument 2. And you can see that we have all of these to do to 2 decimal places. We can go in if we want. We can make, you know, one of them 4 decimal places. Right, it's whatever we want to put in there is how we actually can specify the string. The way this is normally used, it's okay to generate a variable with it. This is perfectly fine. You're welcome to do that. You can also just pop this into a print statement. So we can now do like print outstring, or more likely, instead of putting it in an outstring to begin with, we'll just do the print statement like this. But both are equally valid, and you should be able to do both because we may ask you to format a string but not necessarily print it out. Okay, a couple things to note. There are, you know, this applies rounding, right? It doesn't change R or H or volume. It just rounds them for display. This 0, 1, and 2 allows you to change the order. So if we wanted to put out 1 here and 2 here we could. When the order that we want to put them out in is the same as the order they're in the format statement, which will be probably the most of the time, you can omit. You have to omit them all or none of them. You can omit the 0, 1, and 2. Okay? So that works just as well, so long as this order is the same as the order you want them put out in. Okay, and, you know, if we just do this, then we get whatever the default is, so it's kind of not doing anything for us. All right, what we've been talking about right now, and I think I might run out of time today. Yeah, we'll find out. What we've been talking about so far are built-in functions. And if we want to find out what all the built-in functions are, we can type in help built-ins. And I need another dash here. Right, and these are all the built-in functions that are available. Now, so you can see our print statement, you can see our POW statement, you can see the ordinal statement. And you remember we also had this thing where we could import keywords. Keyword. And then we could look at keyword dot K KW list and look at the keywords that were available. One thing I want to show you is that built-ins you can break. So POW is a built-in, right? It's a function. If we do POW 2, 5, right? Oh, POW 2, 5, sorry. POW 2, 5, that gives us 32. But now we can do something like POW equals POW 2, 5. And now, if we try POW 2, 5 again, we get the error int is not callable. You guys are going to do this accidentally over and over again because it's really interesting to, or usual, if there's a function called list, and you'll do something like list equals and generate a list. So when you see this, it means you've overwritten something that's a built-in and you no longer have access to it. Okay? You can't do that with keywords. So if we do something like true equals 7, we can't assign to true because true is a keyword. So the difference between keywords and built-ins is you can break built-ins. You can't break keywords. All right. Modules are the way we extend Python. I gave you the keywords module. We've done that before. We also have the math module. That's probably the other one that's the most useful. And we'll use that to show a lot of, well, we'll demonstrate a bunch of stuff with that. If you do help math, you'll find out there are a lot of functions that are in the math built-ins, including things like math.py, tau, and e. And then we have all of our trigonometric functions, convert between integers and degrees and radians. We have another version of the POW function. So anyway, there's a lot of stuff that's available in the math function, logs, etc., that will help us out. Square root, for example. We want to make sure that we're able to use those. To access it, right, math is a module. So if you want, for example, the value pi, you type in math.py. If you want the square root function, you type in math.square root. Right? So it's the same kind of dot notation that we've been seeing. And that's because of the way we imported it. Right? We imported, where did I import it? There we go. We imported it, import math. This import takes math, the math module, brings it into your program, and prefixes everything that module defines with the name of the module. Now, there are other ways to do this. For one, let's say we don't want all of our functions. And I'm going to clear my browser for just a second. Restart the kernel. Because I've broken POW and I've imported all of the math functions. So we'll just start over again, clean. Let's say I don't want all of the math functions. I just want square root and pi. Is that what I'm doing? Yeah, square root and pi. I could do from math, import, and then the functions that I want, square root and pi. And if I do this, I no longer need to do the math prefix. In fact, I don't think the math prefix works anymore. Right? So when I import it this way, when I import just a few symbols, I no longer have to use the math prefix. Let's say that I wrote another module that I call math, and now I want to import the real math one, and I don't want the math one to overwrite my symbols. I can also do something like import math as M, and that will bring it in, but instead of putting the prefix math, right, math.square root should still not be there, I don't think. Right? But m.square root will be. Right? And m.pi will be. And m.pow should be. Okay? So those are three nice ways to import modules. They're not the only ways to import modules. The not right way to import modules is, except when we tell you to, and we will tell you to in one of your labs, is something like from math import star. Because what that does is that imports all of the math functions can't remember what that was called. It imports all of the math functions without the math prefix. And what that means is that, essentially what this does is it overwrites any symbols in your code. Yeah, it overwrites any symbols in your code. That was what I was expecting, by the way, that conflict with symbols in the math library. So that means if you had tan defined as something, maybe a color, now all of a sudden you've overwritten it with the tan function. And the reason we don't like to do this is because unless you know everything that's in that function, everything that's in that module that you're importing, you can overwrite things that you don't want to overwrite. Or you can overwrite math functions with your own code later on. So, just like we can break built-ins, this is one of the ways that you break programs. Don't do this kind of There, don't do that kind of import unless, I think we have you do this when we're doing TK enter. But other than that, stay away from this. That's not the best way to do it.
Can you hear me?
You're really buzzing, but I can hear you.
Sorry. I have a question about help.
About what?
About help, the help function.
The help function, okay, yeah?
Wait, hold on, give me a second.
I'll tell you what, we're running up against the end of the class. Can you wait like 7 minutes and then ask me?
Yes, I can.
All right, excellent. So here's putting it all together. The last really big thing is you're going to start writing programs. So we're going to want you to organize it. We're going to be pretty gentle on the first homework. We'll be a little gentle on the second homework. By the third homework, we expect you guys to start having this down. So when you're writing your code, right, put an initial comment explaining the purpose of the program. Doesn't have to be long. Doesn't have to be a dissertation. just tell us, this is problem 1 from homework 1. I'm supposed to make a pig fly or something, whatever it is. After your initial comment, put your imports. Anything you can define up front, all variables and input commands right at the front. Then your main body of computation, and then to the extent you can, all output. Now, these last 3 are a little bit, sometimes you have to intermix them depending on what you're actually trying to do. Sometimes input is interspersed within a while loop or something, so it's embedded in code. But this is kind of like the structure we want to see. So anyway, just kind of follow that. We'll give you more details. There's more details in the submissions guidelines, and we will kind of hammer on this going forward as much as possible. I am going to now go to code in class, and I was planning on starting this a little bit more from scratch, but we're just going to pop this out here. When we started out last week, we wrote a piece of code. Here we go, cylinder.py. Okay, I can't start there. And what we did was we input pi, we input radius, and we specified pi, height, and radius. And what we want to do now is we want to kind of work through this and convert it to something that's a little bit more like what we want to use. Here's my comment. I'm not going to give a better comment, but I would if I were actually submitting this. We're going to use the math function. So we're going to use import math. And because we're importing math, we no longer have to overwrite pi, right? And instead we can use the value math.py here. And is there any other place we use pi? Yeah, math.py here. Okay, so now we've gotten away from using a very poor 3.14159 estimate for pi, and now we're using whatever precision our math module actually specifies for us. We have this radius and the height. These are inputs. We want to do these right at the front. So we want to put our radius equals input. And I'm just going to say radius like that. That looks right. We'll do the same thing for height. And we will spell it correctly, maybe. Now comes in the things we want to do for submitting. Okay, if we're submitting this program, and you can read the submission guidelines for why or a little bit more information on this, but if we're submitting to submittee, we immediately want to print radius after we read the radius and before we do anything else, including height. And we immediately want to print the height immediately after reading the height. Okay, and this is an artifact. This is for you to help you debug better when you're running on submittee, and it's an artifact of the way we have to run submittee. I can talk in more detail later. We are just about out of time. And now the other thing we have to do is we have to say radius equals, right? Radius comes in as a string. So now we have to convert it from a string to either a float or a integer. And I'm going to assume that we may want to make these floats. So we can say radius equals float radius. And height equals float height. Okay? And now maybe down here, maybe we want to print out our volume. And our surface area using our format commands. So we'll put in our format specifiers. I'm not going to use 0 and 1 because I'm going to put them in order, right? And then we just come out here. That's the end of the string, dot format volume, and strip over to the surface area, and I think that should be it. Okay, right, so now we've made a few minor changes to our program. I don't know if it'll run or not, but let's find out. Okay, so it's asking us for a radius over here. What did I say, 5? And then a height, maybe 10. I don't remember what I put. So it gives us 157.08 and the surface area of 345.58. That doesn't sound like that was the values we had before. Oh, one was 2. Let's try running it again. The radius was 2, maybe? Well, anyway, it looks like this is working, kind of. Well, it looks like it's working. And 5, right? Or 5 and 2. We've now taken our program that could only calculate one value because we had these hard-coded. We had a bad value of pi, so our values weren't very accurate. And because we're using more accurate value of pi, our values would have been kind of garbage. We've now converted them into a program that writes out, using reasonable significant digits. And allows us to modify our values at will. So anyway, that's the end of class. I'm going to stick around and do questions for a few minutes. We'll throw this up so I know where to cut it. All right.
Thank you.
You're welcome. And somebody else had questions, right? You're welcome. Thanks, guys.
Thank you.
I'm almost on
I have
time.
a question.
Thank you.
Thank you. I'm going to watch this lecture later when it's up on your YouTube channel.
Thank you.
Okay. I'll try to get it up there as quickly as I can.
Oh wait, we have a YouTube channel.
Thank you.
I'm posting everything to a YouTube channel. I post links directly to the videos in the discussion forum. There's
okay.
There's a lecture videos